Welcome to LNP Renewable System Related. Today we are going to discuss some of the basics of electric vehicle part 15. So if you have missed out part 1 to 14, no issue. Please subscribe to the channel and press the bell icon. In our channel we had created the playlist. In the playlist you can able to see all the missed out videos in those playlist. Okay. So in our discussion we might be using so many abbreviation short forms. So if you have any doubt, please refer to these abbreviations which we are provided here. What are the things that we are going to discuss today in this part? Here we are going to see how a resolver rotor position signal processing system works in an electric vehicle, and what are the characteristics of a different sensing technologies in the electric vehicle, what happens when electrical erosion occurs in a bearing, how to avoid electrical erosion in a bearing, and how conventional and the hybrid electric vehicles looks like, and what are the roles of design and development of a software in an electric vehicle motor development, and what are the operating quadrants of a traction motor, how a traction motor looks like. So when we try to get into the illustration of a resolver rotor position sensor, so the resolver has a digital converter, that is RDC. Okay, we have a resolver which will be fixed on the at the sensing part. Okay, so first and the foremost thing is that whenever we receive a signal from the resolver, with the help of this analog to digital converter, we are converting that analog signal into a digital signal. Okay, and we have a digital filters also. So this is the most important hardware part. Now after that, okay, since we are using the pulse width modulation technique, during the carrier cancellation, what is happening? The signal which has converted from analog to digital, what is happening? It is getting rectified, and by using the proportional integral derivative, we are trying to find out the exact values. After that, what we are using, with the help of the softwares, we are converting, we are trying to calculate the angle calculation using different formulas. So, and finally, and we are trying to get the angular velocity of the vehicle which is running. Okay, and as you can see this video, so whenever it is performing any rotation along with the wheels, so it is sensing precisely and it is providing an electrical signal output, and we are converting the signal to analog signal, and after that with the proportional integral derivative we are trying to find out the angle calculation using the formulas which we had already implemented in the software. And when we made a comparison of different sensor technologies, okay, in the cost wise, this resolver position sensor is more costly. Okay, when we try to know the accuracy also, this resolver position sensor has a very high accuracy. But when we have a sensitivity to the mechanical tolerance, this magneto-resistive position sensor has a good tolerance towards the sensitivity of the mechanical tolerances. But when you go for the sensitiveness of electromagnetic fields, this resolver position sensor has a very good efficiency. So overall, when compared to all the sensors like Hall sensor, inductive sensor, and magneto-resistive position sensor, this resolver position sensor has a good in all the things. Mostly in the temperature robustness, resolver position sensor is working fine. Okay, speed coverages, apart from resolver sensor, all the other three sensors has a very good one. In case of size and installation space, this resolver position sensor has a very efficient size for installing. And for signal process complexity, this resolver position sensor has a high precision. Okay, in case of robustness also, this resolver position sensor has a very good robustness. Okay, and see here, so when there is a normal bearing, if it undergoes any floating or frosting, there is a possibility for electric erosion to happen. So what is happening, see here, when the electrical current passes continuously, owing to it, electric arc is created between the ring and the balls. So because of it, okay, it solidifies and breaks away. So this is the damage. So this is one of the critical damage occurred in the electrical um, bearings. Okay, so when the excessive current erosion occurs, this is how it looks like. In macroscopic level, we can clearly see these damages which is happening inside the bearings. So what are the solutions to the electrical bearing failures? So the reasonable grounding and minimizing the electric field is first thing that we need to do for the bearings. Okay. What's the use of, because if you use the grounding rings, it composed of conductive microfibers, so which will be installed outside the bearings. With the conductive brushes connected to the shaft, the ground rings works as a diverter, directing the shaft voltage to the ground. And in order to improve the insulation performance of the bearing, first we need to raise the impedance between the bearings and the ground. So thereby electrical discharge can be prevented by the insulating layer. Apart from it, we need to redesign the bearings, and we need to use the polymer cages. Okay. Even though when it is running at the very high speed, okay, we need efficient lubricants. So we need to use a special type of greases for the bearings. Okay. And when we're going for a hybrid bearings, we need to use ceramic rolling elements and steel rings for it. So this is an example of how the conventional and hybrid bearings nowadays in our industry we are getting these sort of hybrid bearings. And apart from it, design and simulation is very much important in while we are doing a motor development, because in the designing we might have so many challenges, right? We need to have a reduced motor size, and we need to increase the power density, and we need to improve the efficiency, and we need to reduce the torque ripple which is happening in the motor. Okay, so during the design process, using the analytical softwares of the machines, we are using the pre-sizing of the machine. And next thing is that we are simulating the coupled magnetic and thermal effect in order to have them during the cooling of the machine. Okay, and we are optimizing to reduce the torque ripple, and we are also optimizing for the better NVH performance. And we are also doing the thermal simulation in order to get the optimal thermal temperature distributions. And when we look into the 4-quadrant operation of a traction motor, we can classify into 4 quadrants: model 1, 2, 3, 4. In the model 1, what is happening? Because of the positive torque speed, okay, the vehicle is moving in a forward direction. Okay, and in case of this quadrant 4, what is happening? The motor is in the during the quadrant 3, what is happening? The motor is in the negative torque, so that what is happening? It drives the vehicle in the reverse direction. Okay, it means in order to move the motor or vehicle in the forward, it should be in the model 1, and if it is need to move it in the reverse, it should be in the model 3. Okay, when we are going for a model 2, what is happening? Here the braking mode is there, because of which a positive torque is created, which makes the electric vehicle to slow down before applying the mechanical brakes. Okay, and in the model 4, what is happening? The braking mode is happening in the negative, so we have same function when we are doing for the reversing operations. So when we get into the design approach of a traction inverter, see here we have a transient suppressions, and we have a microcontroller. Inside that we have a proportional integral controllers, we have a communication boards, and we have a PWM converters also. Okay, and outside it we have a DC link voltages, and we have a DC boosters also. Okay, and with the help of this IGBTs, what we are doing, we are controlling the 3-phase permanent magnet synchronous motor. Okay, with the help of the resolvers, we are trying to sense the angular speed. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We can provide the contact details here. So for the PLC programming, we are providing training along with the certification for Siemens, Allen Bradley and Delta PLCs. If you had a plan to work in the GCC countries in the building management and building automation industry, you can contact us. If you are from electrical and electronic engineering background, electronic and communication engineering background, electrical and electronic engineering background, then you can contact us. We are providing the training along with the certifications. And if you had a plan to do design, installation, testing, commissioning, consultancy, training support, then you can contact us for the solar, on-grid, off-grid, and hybrid applications. And if you had a plan to put a fencing for your agricultural farms, then we are providing solar fencing as a kit. You can contact us. If you want to learn the electric vehicle technology basics. So we are providing training along with the certification. You can contact us. Thank you so much.